Hello everyone, this is a question 14 and it's a differential equation question. So it says express 3 over 2x minus 1 times by x add 1 in partial fractions. Okay, so just a nice little intro to the question, a little bit of partial fractions. So we're going to write 3 over 2x minus 1 times by x add 1 is going to equal, we're going to write that as a over 2x minus 1 to plus b over x add 1. And then what we do is we imagine that we're going to multiply both of the denominators, all the numerators rather, by this denominator. So we're then going to write 3 is going to equal a times by x add 1 plus b times by 2x minus 1. Okay, so now we've got to, there's lots of different ways we can do this, but I like to use the substitution method. So I'm going to think, what's my value of x? I'm going to put in here that's going to eliminate a and help me to work out b. So I'm going to say let x equal minus 1 to start off with. So therefore 3 is going to equal 0 plus b times by 2 times minus 1 is minus 2, minus 2 minus 1 is minus 3. So therefore I get that b must equal minus 1. Okay, so that's my first one. Then in order to make this bracket equal 0, I'm going to say let x equal a half. So that's going to give me 3 is equal to a half add 1, which is 3 over 2a. And then we're going to have plus 0 when we've got a half in that bracket. So now I can times both sides by 2 and divide both sides by 3, and I get that a is equal to 2. So I've worked out what my a and my b are for my partial fractions. Okay, so we can say therefore that we have got 3 over 2x minus 1 all times by x plus 1 is equal to 2 over 2x minus 1 minus 1 over x plus 1. Okay, so that's our partial fractions done there. Good, now let's have a look at the next bit of the question then. So what does it say now? It says when chemical A and chemical B are mixed, oxygen is produced. A scientist mixed these two chemicals and measured the total volume of oxygen produced over a period of time. The total volume of oxygen produced, V meters cubed, T hours after the chemicals were mixed, is modeled by that differential equation given there. So dV by dt equals 3V over 2t minus 1 times t add 1, where k is a constant. Given that exactly 2 hours after the chemicals were mixed, the total volume of 3 meters cubed of oxygen has been produced, solve the differential equation. Okay, right, so solving differential equations. So the first step is separating the variables. Okay, so that's always our first step when we're solving differential equations. So let's have a look at that. So what have we got? We have got our differential equation is dv by dt is equal to 3v over 2t minus 1 times by t add 1. Okay, so we're going to divide both sides by the v and we're going to multiply both sides by the dt. So therefore the integral of 1 over v dv is going to equal the integral of 3 over 2t minus 1 times by t add 1 dt. Now what we've done there is divided by that v and multiplied by that dt. So we've treated dv by dt as though it was a fraction, even though of course it isn't. And at this point you're going to look and think, okay, what's the link that we've got here now with our part A? And we can see that the link with part A is that the answer to the partial fractions can be put in here now. So integrating this is the same as integrating 2 over 2x minus 1 minus 1 over x add 1. Oops, except it's t, isn't it? Yeah. So it's going to be t there. So it's going to be 2 over 2t minus 1 and over t add 1 dt. Okay, perfect. So that's just using the result that we got there from part A. And we've got the integral of 1 over v dv. Okay, so now we're ready to proceed. So let's have a look at this. So the integral of 1 over v is going to be ln mod v. And then when we integrate this one, we're going to need to think about the chain rule backwards. So my outer function is 1 over something. My inner function is 2t add 1. So when I integrate my outer function, it's going to go to learn mod 2t minus 1. And don't forget, I've got to remember to divide by the derivative of the inner function, which is 2. So the 2's cancel out there. Okay. Then over here, the next one's quite nice and straightforward. That goes to learn mod t add 1. Because when we basically integrate, when we differentiate t add 1, the derivative is just going to be 1. So we don't need to worry there about dividing by the derivative of the inner function. Now, the next thing to point out, and this is something that might not be familiar to everyone, is when you've got a differential equation that's of the form learn and learn and learn, when you're adding your constant, it can often help to write the constant in terms of learn as well. So in other words, if I write this, instead of writing plus c, if I write it as learn k, like that. Okay. So now let's think about this. Using our laws of logs, we've got that one add that one is going to become a product. So we're going to have k times by 2t minus 1. The whole thing's going to be divided by t add 1 because that's a subtraction. And we're going to have the natural log of that whole thing is equal to the natural log of v. So now we can revert, once we've got to the stage where we've got learn of something equals learn of something, we can now reverse our logs and write that as v is equal to k times by 2t minus 1 over t add 1. Okay. Now you can see we're almost there, almost there. We just need to now find out what the value of k is. This, by the way, is what we call our general solution, which is when we do not know what the value of the constant is. But they've given us what we call a boundary condition. Notice that they've told us that in the question, exactly 2 hours after the chemicals were mixed, a total volume of 3 has been produced. So they're telling us that when t is 2, that v is equal to 3. So we can sub that information in now in order to work out what k is. So we're going to have 2 times 2 is going to be 4, 4 take away 1 is going to be 3, and then 2 add 1 is 3. Okay, so that cancels, so k is 3. So therefore our equation is v is equal to 3 times by 2t minus 1 all over t add 1. Okay, as required, and that is that part done. Okay, as required. So yeah, that is part B done for 5 marks. So quite standard kind of process there. Right, let's what's next in the question. The scientists noticed that there was a time delay between the chemicals being mixed and the oxygen being produced. And there was also a limit to the amount of oxygen that was produced. Okay, deduce from the model the time delay. Well, let's think about it. So the volume of the oxygen being produced would be 0. Okay, so initially if there's no oxygen being produced, the volume of the oxygen would be 0. So what we're saying is that this v is going to equal 0. So 0 is going to equal 3 times by 2t minus 1 over t add 1. Now the only way this fraction can equal 0 is if the numerator equals 0. So we're basically saying that 2t minus 1 has to be 0. So therefore t has to be a half. This time is in hours. Okay, but it says give your answer in minutes. So it's half an hour. So therefore it's going to be, for C part 1, it's going to be 30 minutes is the time delay. And we work that out by setting v equal to 0 in terms of the volume. And then the limit. Now what we've got to do is imagine that t becomes really, really large. Okay, there's various ways I've seen people do this, but let's imagine t becomes really big. Okay, so we have got 6t minus 3 over t add 1. Now if t becomes absolutely huge, this minus 3 and the plus 1 are going to become negligible. And it's going to become like 6 times some really big number divided by the really big number. So in other words, as t tends to infinity, that expression, 6t minus 3 over t add 1, is going to tend to 6, okay? Because those will become insignificant, the t's can cancel and you're left with 6, okay? So therefore the limit in this question is 6 meters cubed of oxygen that is going to be produced by the chemical reaction. Okay, so 6 meters cubed. Perfect. Well, I hope you found that video helpful. Remember, if you're finding these videos useful, if you could remember to like and subscribe to the channel, then that's going to really help me to keep on making more videos. Thank you so much for watching, and I'll see you in the next video.